10 next. Number 10 says, Bill and Gina each ate 1/2 of their own pizza. Bill ate more pizza than Gina. Draw a picture and explain how that is possible. So for this one, remember how in every other problem that I drew a picture, I said I have to make really, really sure that I draw my bar diagrams the same size, and I have to line everything up so that they start and end at about the same place on the page. And that's so that I can compare them with each other. But for this one, I have to do a little something different because it says they both ate half of their pizza. So I cannot compare these two halves directly, or these two fractions directly with each other using the same whole. So if I'm going to model this, it says Bill ate more pizza than Gina. So maybe this is the size of Bill's pizza, and it says he ate half of his pizza. Well, if Bill ate more than Gina, then her pizza must have been smaller than Bill's pizza because she also ate half of her pizza, but never does it say that the pizzas are the same size. Okay. I'm going to label these. This is Bill's pizza, and this is Gina's pizza. And my question says, draw a picture and explain how that is possible. I drew a picture and now I need to explain. So I'm going to write, Bill ate more than Gina because he ate 1/2 of a pizza that was larger than Gina's pizza. That means that half of Bill's pizza is greater than half of Gina's pizza. Okay. So your answer doesn't have to be exactly like this. There's many ways you could say the same thing. You might have explained it in a different way, and that's fine as long as you recognize that the two pizzas were a different size. That's the only way that Bill's half of a pizza is larger than Gina's half a pizza. Okay. I'm going to move on to number 11. Okay, for number 11, it says order 5/8, 1/2, 2/3, and 2/5 from least to greatest. So I'm going to do a combination of things on this one. I'm going to first use a benchmark fraction. Okay, so I'm going to use the benchmark fraction 1/2. I know where 1/2 is very well on the number line or in a bar graph. And so I'm going to look at my other fractions, and I'm going to look and see which fractions are greater than or less than 1/2. So I see that 5/8, that's greater than 1/2 because 4/8 is 1/2. I have exactly 1/2. I have 2/3, that's another one of our benchmark fractions, so we know 2/3 is greater than 1/2. And I have 2/5. 2 is less than half of 5, so I know that 2/5 is less than 1/2. So this is less than a half. 1/2 is 1/2, and I know my other two fractions are greater than 1/2. So right away, I know that 2/5 is the least. I know my next greatest is 1/2. And then I've got 5/8 and 2/3. Those two fractions I can't visualize in my head. I'm not sure exactly which one is greater than the other. So I'm going to make some equivalent fractions in order to check it out. So the first thing I need to do is think of a common multiple of 8 and 3. So these are my two fractions I'm comparing at this point. I need to know which one is greater than the other. So I'm going to use the space down here under my answer box. I've got, let's see. Actually, maybe I'll do some lists over here. I've got multiples of 8 are 8, 16, 24, 32. Multiples of 3, I've got 3, 6, 9, 12, 15, 18, 21, 24. 24 looks like a winner because I knew I wrote it down over here. 24. So 24 is going to be the denominator that I'm going to put for each of my equivalent fractions. So first I'm going to do 5/8 equals some fraction with 24 in the denominator. Okay, what do I have to do to 8 to make it 24? I have to multiply by 3. Okay, so that means I multiply 5 times 3. That's 15 24ths. Now I'm going to look at 2/3. 2/3 is equivalent to some fraction with 24 in the denominator. So I need to ask myself, what times 3 is 24? And if I know my multiplication facts, I know that's 8. 3 times 8 is 24. So I need to do the same thing to my numerator. 2 times 8 is 16. Well, now I can see why it was so hard to visualize these two fractions, because 15 24ths and 16 24ths are so similar, because 24 little pieces, that's a lot of pieces. That's how many sections my whole is divided up into, 24. And I can see that 15 24ths is less than 16 24ths. So 15 24ths was equivalent to 5/8. That fraction comes next. And my greatest fraction is 16 24ths, which was the same thing as 2/3. So 2/3 is my greatest fraction. Okay? On a problem like this, it's a really good idea to try to use some benchmark fractions to eliminate some of the work. It would have been a lot more work to try to find an equivalent fraction for all 4 of these fractions. So take a look at what you have, and if you can automatically order some of those without having to find an equivalent fraction, you can totally go for it. Okay, now I've got number 13. It's my last problem because I could skip number 12. 13 is actually fairly simple. It just says draw a model to compare 1/3 and 3/5. So I'm going to start by writing my fractions in. I'm just going to draw a bar diagram. I kind of wish I had drawn these closer together so that I could line it up better, but that's okay. I need to split my top bar diagram into 3 sections because the denominator is 3, tells me how many sections I need. And the number of sections we're talking about is one of those three because it's 1/3. So I'm going to fill in 1/3. Down here, I need to set my bar diagram up with 5 sections because my denominator is 5. So I've split my bar diagram into 5 sections. We're talking about 3 out of those 5 sections. So I'm going to fill in 3 sections. And I can see pretty easily that when I compare those two bar diagrams, I can see that 3/5 is greater than 1/3. So I'm just going to write an inequality here. 3/5 is greater than 1/3. And that is it for the problems that were assigned on Monday. If you have any questions about these questions, I highly encourage you to come to Lunch Bunch tomorrow. And I can answer any questions that you have about any of these problems. All of these problems will set you up really nicely to do well on the quiz on Wednesday. Okay, thank you, everybody.